Chapter 10, Section 7, Problem number 11. For the data in Exercise 11 of Section 2, a continuation, as we've been mentioning, of Problem number 11, give a point estimate for the average number of words in the vocabulary of 18-month-old children. Okay, so children, that's across the group of 18-month-old children. That gives us a clue there that we're going to be needing. So our point estimate, we can get that from our regression line. So we have here is our generic regression line. So for substituting what we have in our problem, so we're going to have for A, so our point estimate of Y is going to be 4.85 times our X, which is our 18 here for 18 months, times 18, plus, in this case, it's a minus 56. So essentially minus 56. So our point estimate is, let me jump over here to Excel where I actually did that calculation. As we've looked at, here we are in 711. There are all our previous calculations, all of our data here, and from previous sections that allows us to pull this through. So let's go down here to section 11A. We're going to put 18 in. Let's see if I did this right. We're going to have, okay, D29. That was my B1 hat. So B1 hat times 18 plus my B0 hat, or beta 0 hat, which is plus the minus 56, which is what we had mentioned. Gives me a value of 31.3. So come back over here. So Y, my point estimate is going to be 31.3 words. So, all right, B, construct the 95% confidence interval for that mean value. So we've been looking at in A, the whole point of this is the average number of words in the vocabulary of 18-month-old children. So across 18-month-old children, that average. So we're looking at the confidence interval on that mean. So that's the mean value across there. So we talked about two different types of confidence intervals for point estimates in this section. So this is the confidence interval on the mean. So as we look at that confidence interval on the mean, that's going to be this, and let's see, 100 times 1 minus alpha, oops, not 1 minus infinity, go away, 1 minus alpha percent confidence interval on our point estimate of our Y, plus or minus the T at alpha over 2, and our standard deviation of errors for the sample at epsilon times the square root. Make that really long over a bunch of things. So the square root of 1 over n plus our point estimate value minus the mean of the point estimate squared divided by the sum of the square of the x's. And our t is going to be with the degrees of freedom of n minus 2 in this case. All right, let's jump back over to Excel where we have a number of these things calculated already, so we can put that in to do this calculation and look what other values we need and what values we have here. So as we go to Excel on number 11, we're down here. You can see where we just had done our value here for A. Let me go ahead down to B. So we're looking at now doing a 95% confidence interval for the mean value that we did there in A, that point estimate of X being at 18 for 18 months. So 95%, so our alpha is going to be 0.05. And we come back over here, so we're going to do alpha over 2. And alpha over 2, if we click on that one, I'm looking at that being, in this case, I just put that value in, so that's our D56, so our shaded value here, alpha over 2, which got us 0.025. Our degrees of freedom again at n minus 2. And we've had this one here several times, n minus 2. Back up above, we had our n, which is back up there in D17. So as we get back down here, that's where we have our d minus 2, gives us our 4. So to look up our t at our value of the t distribution at alpha over 2 at 0.025, the cumulative distribution, in this case, greater than the point at points where we have 0.025% of our distribution, that for the t-value at 4 degrees of freedom is 2.776. Again, that's in italics because I took that out of the table. Right, so we've got that information. Now we have to come up with this term that I had just written. So we're looking at the confidence interval on the mean value, and that was the term I had put there. So if we come down here, I did that same kind of plus or minus term, not plus or underscore, plus or minus term. So the plus or minus term is that whole mess. Okay, in Excel it looks like that. Let's kind of talk it through from the formula. It starts off saying that our for the formula from the text, the t alpha over 2 value at our n minus 2 degrees of freedom, that was this first term, the d57, which I'm taking that right there from t alpha over 2, that d57, that value that we had just looked up in the table. And that's going to be multiplied by the sample standard deviation of errors, or S epsilon. So let's see, that's going to be d39. So up here, d39 in red, we have the S epsilon. Okay, then that's multiplied by the square roots. I've got back up here in Excel, I've got the times the square root of a whole bunch of things. So I put all these in parentheses to try to make it make more sense to me so I don't mess up what's going on where with pluses and minuses. So I've got the first, it's going to be the square root of 1 over n. So up here I've got 1 divided by d17. d17 looks in a purpley color. Just come back up here. d17 is purple at the n, so 1 over n. And then to add to that, this whole value here. So this whole value then is in parentheses, and that's green minus reddish. So let's see, d52, back down here. d52 was my xp, so my point estimate of at x that I'm looking for. So that was at d52. I'm subtracting from that this color, which is this color here at g10. So xp minus x bar. Okay, so then I'm going to multiply that by xp minus x bar. Again, the same thing, so in other words, squaring it. Then dividing that by the sum of the square of the x's. So it shows a d19, there it is. d19, sum of the square of the x's. Then I close the parentheses on the first part, then close parentheses on the second part, which does the square root. So when that actually calculates that all out, I get the plus or minus term being this 7.05. So let me come back over here to where I am. So it's my YP value. So 31.3, the YP at that P, this one. So 31.3 plus or minus 7.05 words gives me the 95% confidence interval at XP equaling 18 months. So there it'd be. Okay, great. And then C comes back to asking us, is it valid to make the same estimates for 2-year-olds? This takes us back to a point earlier in the section where it talks about doing our confidence intervals and estimating based on where we're doing our estimates and the data that we have. Let's go back to and look at our data. So back here in Excel, if I scroll back to the top, I look at our data up here in Excel. X is valid. Let's go ahead and highlight that. So X is valid from 13 up through 18. So the data I have is from 13 months to 18 months. If I kept looking out here, I don't have any data out at 24 months. So I really don't know what goes on out here. We don't have any evidence that it continues. It might. We don't have any evidence that it doesn't continue. We just don't have any evidence. So doing things out here in this area and trying to make estimates out where we don't have any data is not a good thing. The point of this question, let's go back to it again, is it valid to make same estimates for 2-year-olds or 24-month-olds? The answer is no. We do not have data going out to that point, so no. Not data at that value, or value is outside the data range. So we shouldn't be making estimates of things that are outside the range of our data. There we go. Problem number 11.